everyone, and welcome to Beyond the Model. I hope you've had a fantastic break over Christmas and New Year. For those of you that follow us, you might know we're building a community for machine learning tech and robotics founders, engineering leaders, and engineers who are changing the world around us. As part of this journey, we're speaking with some of the most impressive leaders in the industry. And today I'm joined by Guillaume Binet, who is the founder at Copper Robotics. Welcome, Guillaume, first of all.
Yo, thank you for having me on the show.
It's great to have you here, and I hope that your New Year started out well. For all our listeners, Guillaume is a founder of a startup called Copper Robotics. Copper Robotics is a startup that's developing a Rust native robot SDK that empowers developers to bring up the next breed of smart robots. He's previously led engineering teams at UAV startups, a company called Skyways, a couple of big autonomous driving companies as well, where he led software teams, Motional and Argo. So, Guillaume, it's an absolute pleasure to have you here. I really appreciate you coming on, and really excited to learn more about your journey.
No, thank you so much.
Fantastic. So, I think a great place to start would be you kicking off and talking us through your career journey so far. So, some of the work that you've been doing over the last 20 years, how you got to the position that you're currently in now. Perhaps if you could go back and talk us through your background and how you got to here.
Oh, of course. Yeah. It's all a continuity, right? A career is just like events that are linked to one another, right? And I'm a good example of that, right? If I start, I can go way back, right? I've always been fascinated by computers, right? They were like very. You can imagine myself as a kid, like in the 80s, right? You had those like first computers like showing up in families, right? Suddenly, at the heart of what I think your nexus is, right? You have this thing that can do like smart things, right? And that has been like always like what I've always been interested in how it works, how can you use that, and so on. Like way before it was like ubiquitous, right? And but it didn't end there, right? Like when I could see that those computers that were kind of abstract objects, right? Like where it was basically like a glorified calculator, right? Could do things in the real world. I was mind blown, right? That's why I went to telco, right? Telecommunications, where around that time, like in the 90s, right? Telcos were moving from like dumb telephones, right? To actual like networks and computers, and they were interacting and routing, and suddenly computer had like interactions with the real world. It could ring your phone, right? That was like back then it was like, whoa, what was going on? Now it's like so boring, right?
Yeah, so
But
we're going back to times before dial-up internet now, right?
yeah, exactly, right. Like literally ISDN, like the first times we had actual like digitizations of telecommunications. That was a revolution, right? And but yeah, even though like software engineering and so on has always been my passion, right? I'm really deep into this, right? I always saw that as a tool, right? And I've always been interested by a bunch of things, right? And that will show up like a little bit later in my career, right? We always loved like, I don't know, electronics and how things works and so on. A very engineering like spirit in the background, right? And like fast forward like years after that, like of course I went through like Google and like the cloud and all those kind of things, right? Where like telecommunications and computers were basically linked up, right? When I could actually work in robotics, I was like, this is my dream job. This is my final my final goal, right? Suddenly you
Land on robotics, Guillaume.
that
You obviously started out, as you mentioned, building cloud software at Google. So why robotics?
so that's interesting, right? Like so it was at Uber ETG, right? Like the branch that was doing those self-driving cars for Uber, and they were in need of like people that were deep into computers, basically, right? They understood like pretty early on that that wait, not only you need to basically develop algorithms for like a robot taxi, right? For a robot you put on the public road, but you need a solid infrastructure that is actually running those robots. And there was a team actually led by another Dan
Right.
that was there, and they developed their own thing, right? Their own like framework to actually power those robots, and they needed like people pretty deep into like the technical side of things on like bits and bytes moving on the robot.
Okay, fantastic. So talk us through your journey in robotics then. So I know you worked on the self-driving car side for a while. So not Aurora. It was Argo AI and Motional where you worked. Yeah, talk to us a little bit about that, and also kind of your progression into a founder. I know you've recently founded your own company, so good to learn about that as well.
Sure. So that was an interesting transition for me, right? I've like switching from software engineering to something that is a little bit more holistic, right? Like with a robot, right? And what I realized like quickly is that robots are very deeply linked up, right? You cannot very like in software, right? You can really abstract yourself. You can make an API, and the other team will take those messages and so on, right? On a robot, it doesn't work, right? Like like literally everything is actually really bound together, and a small hiccup in a networking thing somewhere can actually have like impacts on algorithms on the other side, right? And myself, like to come back to my career, because I was kind of this jack of all trades, I could make links like that, right? That was kind of I think the unique value proposition I was bringing there, more than just bits and bytes. Could understand like, wait a second, you have some tolerance in your mechanical thing that interfere with your sensor, and that makes noise on your algorithm, right? And when you look at Argo AI, for example, right, that's how I kind of that was really my hockey stick in my career. I joined as an early employee, but I grew with the company, right? I grew into understanding like that end-to-end product, where you can help people, right? Like you can say, you know what, I understand what's going on. You don't see it from your vantage point, right? But myself as a leader, I could say, you know what, talk to this person because I think they had an issue that might actually I don't have an impact on your job in the company. So really here I started like as like a first line manager, then went director, VP. And that was really my hockey stick there, right? Really growing the company from I was one of the early employee to I don't know, we were like 2,000 people, 3,000 people at the end. So so that was an amazing like 4 years I spent there.
Yeah, no, I was just saying it's amazing growth. To go from an early engineer to growing such a big company in a short space of time. It's obviously a huge growth area over the last few years, autonomous driving. We're only starting to see the tip of the iceberg now, I think. But it's great to, for anyone who doesn't know, some of these companies have been around for 5-10 years now. And we're only starting to see the technology on the roads today. So it's always great to understand the hard work that goes into scaling these companies. And it's really fascinating. I guess you've had a very successful career over the years, Guillaume. In software. You've kind of worked your way up into management roles, VP of engineering roles, pretty big organizations that you've managed and overseen. What's your advice to anyone who perhaps is a software engineer who's fresh out of school, looking for the first job, or it could even be someone who's mid-career who's just looking for some advice and some inspiration? What would be your top tips for aspiring software engineers in the industry at the moment?
So amazing question. So the landscape is kind of changing for like junior engineers, right? And but I strongly believe that for like if you are looking for really like a very efficient company, teams doing like something like that is actually changing the world, right? the fundamentals don't change, right? So what changed? It's the elephant in the room. I think that's in the title of your podcast, right? Like new tooling, like based on large language models, are actually changing the way we think about how we build software, right? And that does apply also to robotics, right? Like yeah, you might actually almost delegate to an LLM like part of your daily routine, like in terms of like yeah, making tests, I don't know, building algorithms and so on, right? So what does it mean for somebody that is now starting? It's very tough, right? Because those tasks, right? Like when you think about it, like the things you would basically delegate to an LLM, it was actually what you would take, I don't know, an intern, for example, to do, right? Like say, you know what, I have this little scope thing, like, yeah, that's something yeah, I know I can put you on like on a successful path, right? Doing this like small scale, like before you can get like larger scale. And that's exactly what LLMs are doing, right? So you, as like a new person on the market, right? You need to differentiate yourself from LLMs, right?
Yeah.
And again, it means that you need to demonstrate that you can do things that LLMs cannot do, right? And you're in luck because all the things LLMs cannot do is the thing that has not been done before, right? And I see that every day, like building Copper, right? I do have like a co-pilot and so on helping me and so on, and then it fails like hard with Copper, right? In general, Copper is kind of innovative, right? I'm doing things not the way they were used to be done before, and I tell you, it doesn't understand crap about what I'm doing, right? So
Yeah.
little scale stuff, good, right? But the other things, no. So yourself. When you'll go on the market and what you'll have to show to this like hiring manager on the other side is that you could actually bring to life projects from end to end, right? LLMs cannot do that, right? And new things, yeah, like even if it is small scale, even if it is like just bring some novelty or something fun on the topic, something that shows that yeah, you're interested, that you are willing to push the buck, right? And show a little bit your grit and leadership, right? An LLM cannot put that to a team, right? But even a young engineer can do that, right? And that's some aspects like as a hiring manager myself, I'm looking for like somebody passionate, and somebody that will really like push the boundaries, right? And kind of like
Yeah.
move the status quo, right? And say yeah, bringing new idea to the team and so on. So those are the key things I think I would look for, like for either like software engineers or like roboticians in general.
Yeah, fantastic. I think the main takeaway from that, Guillaume, is innovation, really, isn't it? Someone who can move the needle and can build products from scratch, not necessarily relying on existing models and infrastructure, but actually being able to develop their own. So I think it's sound advice to anyone who's listening, really.
And
Yeah.
and really don't be shy, right? Failure is good, right? Like when you are trying something new, you could show me like your old like GitHub repo where you try something and you said, you know what, I tried this thing, it sounded like a good idea, but it doesn't work.
Yeah. Failure
So
is
this,
everything,
this is
isn't
what
it,
I'm
really?
looking for, right?
The only way you can grow as a software engineer and even as a person is by failing.
Exactly. That's how
You
you
know,
learn.
until you've solved a problem, you're kind of blind to things, aren't you? So yeah, fascinating. Another subject I wanted to dive into as well, just whilst we're on the subject of your career, is scaling teams. Obviously, for anyone who doesn't know, I'm a recruiter, so I build engineering teams at a number of robotics companies. You know, I have my thoughts on this, but it's always great to get sound advice from engineering leaders like yourself, Guillaume. So, yeah, what advice could you give to business leaders who are in the process of scaling your teams? I'm sure this is something you're doing as well. But yeah, what are the main things that have helped you over the years?
Yeah, so I'll try to skip the usual stuff. Like, of course, when you are growing teams, you need to be very careful, right? This is a daunting exercise, right? Like you can fail. I failed like in some occasions, right? And you know the A player hiring A players and so on. That is actually very real, right? Like you need to always have your bar like super high as a leader, right? And you should be really proud of having anybody in your team actually in the, I don't know, interviewing other candidates, right? You should blindly say, you know what, if this person tells me like that person is actually exceptional, let's go, right? So yeah, that's classic advice, right? But also, right, I would like to and I'll loop that with the previous discussion too, right? I feel that there is like something that might actually kind of backfire with like this new environment we were talking about, right? You as a leader, like, can have the same tendency, right? Like with those new tools, you'll say, you know what, now I need senior engineers. It makes sense, right? Compared to like, let's say, like what we just said before. You say like, you know what, like all those senior engineers, I can basically morph them into like super engineers, right? Because they are equipped with all this tooling and they can produce like thousands of lines of code every day because like, oh, they can be demultiplied. And we need somebody that has like a lot of like experience and so on to be able to do this, right? And but thinking about like when you are building a team, you are not building you are building almost an ecosystem, right? You are building something that needs to actually survive for years, right? And kind of I don't know, like refresh itself. You'll have like people that leave and new people coming in and so on and so on. So beyond like organizing your I don't know, your continuity, right? You need to think about the people themselves, right? If you put like just individual contributors as seniors that are just like superhumans with this tooling, will they learn? Maybe not, right? You keep them, basically you ask them to do exactly the same thing, but more of them, more of them, right? And that's, for me, that's a red flag when you are a manager. When you have like a successful person and you ask them to do the same thing but more, do they grow? Do they learn? No, right? Like that's how. And who's next, right? Like basically, if you have only like senior engineers, who is growing in your team as junior engineers to replace them? So that's something I think a question you need to ask when you are balancing your team, when you are growing your team, is that you need something like you need junior engineers to be able to themselves learn, even if, yeah, maybe you could see that, oh, maybe they are like half like an LLM could do, right? But think about your senior engineers. They might also want to grow their careers too, right? They might want to actually start to coach them, right? Coaching is actually good for them. That help them to grow into their understanding of what they are doing and like deep understanding, right? And also they might actually jump into leadership at some point, right? So that would be my advice, right? Like especially now, right? Do not neglect the balance of your team, right? And the fact that, yeah, there are humans that wants to grow in their careers. And if you focus just on productivity, now it will backlash like bad, both in terms of like replacing your senior engineers and your senior engineers that will want to do something else, right? So that's my 2 cents on that topic.
Yeah, fantastic. Yeah, great to hear your thoughts on that. Obviously, keeping the bar high is super important. I don't know where these statistics are, but there's a statistic somewhere about making a bad hire. One bad hire can cost you three good hires or something. Um, so yeah, I completely agree. The bar should always be high, and having that balance, as you say, having a mix of seniorities in the team. People who are fresh grads, PhDs, who are just super willing to learn, be really hands-on
Yeah.
with the coding. But then you've got seniors and tech leads who perhaps want more mentorship exposure. That's challenging them in their career. That's taking them to the next level. And that's kind of moving them towards a management role, essentially, if they want to go into that, or, they can really just refine their engineering skills from more of a technical leadership perspective, working on the strategic side of things as well. So, yeah, I think
Exactly.
you're
Right.
spot on with all of that. And, yeah, it's a difficult one, keeping people challenged and happy in work. There's always things that can be done.
Yeah.
But yeah, no, that's super helpful. So just wanted to pivot the conversation a bit now. Obviously, talk a little bit about the industry in general, where we are right now, what's going on, kind of. I think we'll probably talk about this more from a software slant, given your background, Guillaume. But yeah, like what's going on in robotics at the minute? What are the main kind of industry trends? What should we be looking out for? Yeah, talk us through that in a bit more detail.
Yeah, so amazing question also, right? Like that's something like this is why I started Copper Robotics, right? Because I saw those changes. So let me try to give you a little bit like of kind of perspective in terms of like robotics is not new, right? Like I remember I was in a preparatory school, like we have like scientific, like like to become like an engineer in France is a little bit different. You have engineering schools, and just before that, you had like those like 2 years where you are doing only math and physics, right? And they, it's super hard and so on. So the school, right, to motivate you, like as an engineer myself, I was like over this thing, like bad. I could not see an equation anymore, right? Say, you know what, we'll show you a little bit what engineering is, right? So we went to Poissy in 1993 around that time, right? So it's old, right? And we went to Peugeot. It's like a car manufacturer in
Yeah.
France, right? And it was almost entirely automated. Think about it, 1993, right?
Wow.
So robotics, it's not new, right? It's not new at all, right? And
What was automated? Was it on the car on the vehicle itself, or was it in the factory?
the factory itself, right? So
Wow. Okay.
basically, it was funny because what they were talking about back then was already like, you know what what do the robots cannot do, right? And there were like two stupid things. So we were seeing like people moving carts, right, around with the
Yeah.
parts. So basically, this kind of like autonomous vehicle thing, right? Like basically people are trying to not bump into anything and deliver the carts to the next line, so the robots can solder them and so on, right? Like, literally, this thing were from like sheets of steel to like a car
Yeah.
that you can run on the other side. It was impressive, right? Like this, I was like, what? And a bunch of robots in the middle, like soldering them and so on, right?
Yeah.
And so that was one. And another thing that shocked me back then, right? The robots could not place the windshield. So they had like three people carefully like adjusting the thing so to be sure that the joint is actually well centered and can do that. I'm pretty sure now it's gonna be it's probably a robot right now, right? So yeah, what does it mean about like the industry today? It's kind of splitting. There is a kind of a splinter, right? And you see it already, right? You have those KUKA of the world, those like old robotics from those 90s, right? Companies hugely successful, right? They're everywhere in the world, in China, in Korea, and so on, like building those like those robots that are doing exactly the same soldering point over and over and over, right? And but they try to actually, now that we have like those kind of higher level algorithms and so on, they try to make those robots smart. But this is not at all where they are coming from, right? They are coming from a world of reliability, very mechanical world, right? Doing exactly the same thing, right? So it's all about like predictability and basically be sure that those people putting those lines together do not lose money because this thing is stopping in the middle, right?
Yeah.
So that world, right? The other world in robotics that it's so funny because like I meet them both, right? Are very like on the theory side, right? Like people like a lot of like research and so on, and they are coming from the other way, right? They are building smart robots, but they do not care at all if they are reliable. They want that thing to work once, like make their paper. It has been cited. We are good, right? And accepted, and then the robot you see a bunch of those robots like I don't know, accumulating dust in those like hallways of universities, right? But now the third stage today is we need both, right? Like we need like basically those very smart robots, but also reliable in the real world that are reliable, right? And that is the challenge you see today, right? Why don't I have like a robot like serving me coffee today? That's because of this, right? It can barely actually, I don't know, take up the dust with like my iRobot, little robot going around, right? But anything like smarter than this, that's a challenge. You see like
Yeah.
billions of dollars invested in self-driving, right? Because again, like everybody like in the industry today are rebuilding their entire toolkit every time they want to actually build that activity, right? So that's why I build Copper. That's really to embrace this kind of like merging of those two like high level requirements between something that is usable every day and reliable and something that is smart, right?
Yeah, amazing. Yeah, obviously robotics has been around for years and years, as you say. I don't think a lot of people realize, I think the first example of a robot was like a spring-loaded vehicle, right? So you wind it up and it will follow a specific path, and it was automated to some extent, but it's not like what we expect and understand today. So I think there's a lot of traditional automation still around. This seems to be a huge growth area. It's building the intelligence and building the AI for the robots so that they can interact with humans. They're able to perform tasks autonomously, learn on the job as well. This is just such a huge challenge and a huge challenging area. So there's lots of companies out there who are trying to really develop this technology, and it's not easy. There's a lot of money going into it, but no one's really there yet. So some huge challenges. What does that mean for software engineers specifically then? Like what are the challenges that they're facing in terms of making this technology a reality?
Yeah, that's a good question too, right? Like, I always use the parallel with the gaming industry, right? Like games went through almost the same transformation as robots, but I would say like robots didn't make this transformation yet, right? We need to make it, right? So again, let's go back to the 90s. Sorry, that's going to be a very like early 2000s. Okay, I give you early
90s is good. I was born in the 90s, so we can start with the 90s.
So you probably do remember that, right? Like games, in the like let's say early 90s, right? We are very simple, right? They were the KUKA in robotics, right? You had like game studios doing everything, like really from bits and bytes to graphics to everything, and you had your game, right? Like up to remember like Doom, for example. Doom was the first one where
there's a Nintendo 64 game, right?
Yeah. So that started to change. That's when the industry started to change. And what actually what changed, right? Like first the new hardware, right? You had GPUs, right? In so early 2000s, right? 1999, right? Like GPUs started to come up, right? And that opens up like way better games, right? And it kept on coming. Like every single year they were like doing like twice or 5 times like faster. Like it was nuts at the beginning, the progress in the GPU world, right? And but added to this, again, it's like in robotics, like suddenly teams were faced with like, hey, your thing with graphics and like linear algebra and all these kind of things. Like I'm a storyteller. I'm a game mechanic engineer, like creator, right? Like you cannot ask me to know what a quaternion is, right? So that's where new tools started to get developed, right? Because like they needed to. If you leave like those like really people that were really on the creative side that had no background into like either like computer architecture, right? Like it's like almost a supercomputer you need to actually program, and like all those like geometry and stuff like that and math, right? You're up for a bad day. Like they have no idea. It's really complicated to develop, right? And they realized quickly that they need a tool for those people to keep them creative, right? Keep them on the edge of like game mechanics and not deal with bits and bytes and synchronizations on buses, because those computers are getting like very complicated, right? And that's the birth of like game engines, right? So you had the Unreal Engine that started, and like a bunch of other ones, right? And they started to basically kind of abstract a little bit the hardware that was really complex, and basically present an API for those like developers that makes sense to build a game, not to build a system, right? And I really believe that that's the thing, the transition that actually robotics needs to have, right? Yeah. Why it costs like billions of dollars to build like an autonomous robots today It's because, nobody has any tool to actually be able to comprehend the complexity of computers that now needs to be embedded in those machines, right?
Yeah.
And there are other factors, right? Like that are kind of like holding a little bit the software and robotics side of things. Is like so the language like everybody uses is C++, and C++ is a very I don't know system-ish language, right? And it's very complex. It has like a lot of baggage, like for like 30 years, right? Like, and today, I mean, I think you cannot find somebody on Earth that really understands C++ end to end. Think about it, right? Like you ask people to develop in a language they do not understand, that nobody understands, right? And you ask them, you know what? Let's make something that can actually drive around people in a row, right? On the road, right? And they will have like a lot of unattended effects, right? Like doing that, like you always are surprised, but you have no idea how you can be surprised with C++, right? And I spent nights like trying to debug like self-driving cars with like C++ code. Like I swear I read it like 5 times. It's okay, and it was not, right? Like a hidden like effect in the middle of it, right? So and but the change is hard, right? Like you have those like I was saying, like those people coming from academia and they're tooling like it's ROS, the robot operating system. They are in this old model, right? Like saying like, yeah, we need flexibility, we need a lot of things that serve experimentations, right? You have a lot of people coming from the C++ world because like, yeah, we always use this tool. Why change, right? So there's a lot of inertia in that system. But I think if the software industry for robotics kind of like really jump to the next level, they need a kind of rethinking of what they are doing, right? And we will be stuck with no robots for a while if we don't realize that, we need something like a game engine, something that completely changes the paradigm of how we build robots, so we can jump to the next stage in terms of like, bringing all this complexity, algorithms and so on, in a simpler manner, in a reliable manner on some hardware.
Amazing, yeah. So this ties into what you're doing right now, Guillaume, in terms of developing this software development kit for creatives. I know your technology is powered by Rust. So talk to us a bit about Rust. Why Rust? And I know this is a huge this language is exploding at the moment. Every year it's getting bigger and bigger, more people adopting it. But what was the decision behind that?
Yeah, so very good question too, right? So I started to actually use Rust at Argo AI, but it was a little bit too early. The team was like not super happy about it, because like again, like for all those reasons, right? But it was really too early. And what I saw in Rust is little bit like what are basically the push I had from, for example, like automotive manufacturers, right? Those OEMs, right? What do they ask from one code base from one of their supply chain, right? Like a company, right? They have a very like prescribed kind of way of doing things that kind of sounds silly sometimes, but but some of their rules in terms of like, I don't know how you make like some software for your ABS, right? You know what? This microcontroller that is in your Birkin system, you better have this thing not crashing, right? And that brings like a bunch of things that are absolutely makes like software development for those kind of code bases horrible, like literally horrible. Like you need to understand exactly what you need at the beginning. You have like a bunch of tooling you need to add to your C++ chain that keeps on pestering you on like stupid things. You remove like a bunch of constructs in your language, right? So basically you are writing C++, but it feels like you are with your chisel and trying to shape some stone. Like that's horrible for a developer, right?
Yeah.
What I saw in Rust is that basically you take the great part of C++. It's fast, right? It's close to the middle, right? You have a good understanding of what it is doing behind the scene, right? And you basically, by construct, include in the language itself everything that those tooling that you would need to add to C++, but within the language, right? And it talks to developers, right? Like the Rust compiler will basically explain to you, you know what? You are doing something, and I don't see how it might be safe. You see? So sometimes it's kind of pestering a little bit, right? Because you need to understand, like, why is it bothering me with this, right? But more often than not, you realize as a developer, it's like, yeah, indeed, Mr. Rust compiler. If I were to do that, there might be a use case where somebody might misuse my API and so on, and that might actually crash or do like an unintended behavior, right? So that's it, right? Like basically the name of the game in software development is moving to the left, we call that, right? Basically, you need to catch potential errors as soon as possible. Why? Because it's not expensive, right? Like if you are compiling your software, right, and the compiler tells you like, that's probably a mistake, that's like a few dollars. Oh, sure, yeah, I'll change that, right? If you catch that in like a CI/CD, basically, when you start to basically try to push your code into your production environment, and some kind of external tooling start to try to explain to you what you did wrong and probably made a mistake out of it, that start to be expensive. You're past that. You're already there, right? Like come on, I already switched to something else. Or wow, like you asked me to change something, right? But fundamentally, those tooling cannot actually go all the way as Rust can do, right? So you will catch stuff that is actually in production or in testing, right? And that is really, really expensive. Every time we are talking about an order of magnitude more expensive. And most of the success of Rust, right? And I think for all those managers out there, right? Like they need to understand that's all about cost and actually kind of I don't know, your team going back and forth.
Yeah, and it's the time that you save, isn't it, really? Time is money in software, and if it enables developers to be to identify issues much more quickly, that's a huge
exactly right.
Huge impact that it can have. Okay, fantastic. So where is what does the future of robotics look like? Particularly in software over the next, I'd say, 5 years. I mean, what are your predictions? What do you think is going to happen?
So I believe there will be some standardization that is on some new tooling, like a new ecosystem, right? For all the reasons I mentioned before, right? And that ecosystem will kind of mature, right? Like maybe it's going to be around Rust, right? Probably. But instead of having like probably one company kind of like hogging the thing, right? That you see that like with NVIDIA is trying to do that. All the robot manufacturers are doing this and so on, right? As a company owner, I don't want to be completely tied to one vendor. So you need a kind of the web of robotics, right? Really something that is well targeted towards these new constraints, like in terms of like product and something that can be fairly high level, but very open, right? Like it needs to be like developed in an open source model. Again, like replicating a lot of things you've seen, like game engines often are open source, right? Like OSs are open source, Linux is open source, right? And you've seen a lot of success into this. Like people can build on like those good ideas and kind of like, okay, you know what? Now that the base is good, right? Now we can add components and so on, right? So I see this, right? We will get past this like faster horse thing where this new breed of companies. I'm thinking about Rerun. I'm thinking about Foxglove, like all those like new companies, like really rethinking about like, wait a second, what are we doing? What are the new challenges for robotics? And they are focusing on one vertical of it, right? Very well, be it like calibration, be it like data analysis, be it like replay, be it like, I don't know, data representations, all those kind of things, right? And and link them together through like standards that make sense, right? Like unlike kind of unlike ROS, unfortunately, that is already existing, but you see the limits pretty quickly, right? And
Yeah.
yeah, not to plug my own thing, but Copper Robotics is all about that, but about the runtime on the robot, right? And we see that today that Copper starts to be the kind of the nexus where like people start to attach themselves into that project, because like everything starts from the runtime, how you run your workload on the robot, and a lot of tooling will get derived from this, like how you represent data, how like deterministic your stack is, right? Basically, how can you run something on the robot and you can actually replay it. That's super important for like machine learning workloads, because like you can imagine if you add some randomness and you have like some requirements in terms of like safety, right? If you cannot prove what you're doing, because whenever you are trying to reproduce your what happened on the real world on your robot, you cannot say, my thing is safe. Like, 98% of the time it does from the same input, it does like 98% the good input. You're like, wait a second, this is computer engineering. This is not like, I don't know, like a casino, right? So you need those kind of certainty that ROS cannot give, right? And that, I think, from those like good like first principles, right? That the company, basically the industry learned like the past 10 years, right? You'll see those new tools kind of like growing, right?
Yeah.
And also the pace and the cost of robots or developing robots going like way down, right? I'm expecting like, I don't know, a couple of order of magnitudes between like, instead of billions, you should have tools that give you like tens of millions of dollars to give you like, I don't know, or let's say 100,000, $100 million to be able to make like a safe autonomous robot. So look out for this. I think that's gonna be the next like kind of like big wave in robotics. Like suddenly we get serious about it, and you'll see like a lot of new robots coming out of that new wave.
Fantastic, yeah, amazing. Well, thanks for running us through all of that, Guillaume. Yeah, really fascinating stuff. Like, yeah, your career over the years, all of these challenges in robotics and where we're heading. It's great to get your perspective on everything, and I'm really excited to hear more about this area of software development. Yeah, I'm excited to hear about the adoption of this sort of technology. I think that being able to build robots for much cheaper is hugely important, as these particularly for robotics companies who are going from ideation stage. They've got done a lot of research, built out initial product, but now it's all about taking it to market and making it available to buy for consumers. Cost is really everything, and time as well. So if there's something out there that can save us time and money, I'm sure that it's going to be super useful for the industry. So I think we'll wrap up here. Thank you very much for joining. For everyone who's listening, please give us a follow, or join the group that we've set up. Our community, as I mentioned, is Beyond the Model. Please follow Guillaume and Copper Robotics. Lots of exciting stuff that's going to be coming out of Guillaume's company in the next few months and years. So thanks again. Is there anything that that you'd like to finish on, Guillaume? Anything that you'd like to plug to our community?
Of course, there is, right? Like, so yeah, if you're passionate about that, like making computer go brr, right? On robots, we do have like I was saying, like everything I said really applied to Copper. It's open source, right?
Mm-hmm.
So feel free to check it out. Like we'll put in the comment below the URL, the GitHub repo, right? We have also a Discord channel if you're interested about like talking about those higher level topics, right? On even Copper or Rust for robotics. Also, we have also like a channel that actually bring up like all people from all backgrounds, like algorithms and so on, that wants to dive into Rust and see how do I build a robot with Rust, right? So we have that too. I'll link that too in the comments. And also we have two like internships that we are opening this summer. We were talking about like young engineers that needs to learn and work on something that is kind of fun and fascinating and really going into new things. Yeah, so again, the best way to get an internship at Copper, go in. We have a bunch of issues on our GitHub repo. Pick up one and show us your skills, and you'll get an awesome summer.
Amazing. Yeah, thank you. An exciting opportunity there. Firstly, for anyone who's graduating, could be interested in working with Guillaume on this technology, and for any business owners that are listening, please get in touch. As Guillaume say, we'll drop the links in the comments below. And thank you everyone for joining us. Thank you, Guillaume, again, and we'll be back very soon with another episode for you all.
Thank you so much for hosting me, Dan. Thank you.
Cheers. See you, Guillaume.